the turning point of a curve. Now, because this is a minus x squared right away, what shape do I know it is? I know it's an n-shaped curve. You go with that? The only thing I don't know is where exactly it hits the curve. Does that make sense? I don't know. I don't know if it hits it in the double negative, double positive, one negative, one positive. I don't know anything about that. Is that cool, you guys? Now, what we're going to do is we know that the maximum. Why does it have to be a maximum? Huh? Yeah, it hits up there. So what we're going to do is we're going to differentiate once, and we're going to say we know what happens when the slope is 0. So we differentiate once. Okay. Not yet, because I'm differentiating. So differentiate the 4, gone. Differentiate the minus 8, x minus a. Differentiate the 2x squared is minus 4x. I know it has to equal 0. I'll just bring the 4x to the left. 4x equals minus a. And then x will equal minus 2. Does that kill you guys? Now, what happens next is it says turning point. Turning point indicates an x and a y value. I only have a x value. So what do I do now? Sub it back in. If only they're all like this, okay? Sub it back in. You get, that's 16. That's minus 8. It's 20 minus 8. 12. My point in question is minus 2 and 12. Is that okay with you guys? Okay. Do question 3. All right. This is a u-shaped function. Means that the slope is 0 at the bottom of the function. First derivative, the y dx is 6x minus 6. You solve for x, you get 6x equals 6, and then x equals 1. You sub x equals 1 back into the original. So you get 3 times 1 squared minus 6 times 1 plus 4. And what do you guys get? 1 as well. So this means your minimum point is the point 1, 1. The first thing, you're going to see the word nature of a turning point. Okay? When you see the word nature of a turning point, you do what's called the second derivative test. The second derivative test looks something like this, and it's the opposite of what you think it is, all right? So, using the second derivative test, give me a sec. The second derivative is bigger than 0 for a minimum, and the second derivative is smaller than 0 for a maximum. Now, see the way this is an x cubed. What did I say about x cubes earlier? How many turning points? Do you read there's 2 of them? Okay. This means I'm going to get 2 x values and 2 y values. Okay. So I differentiate the y dx, and I get and we know that there's 2 points where the slope is equal to 0. Yeah. 2 points where the slope is equal to 0. So bring the 3 to the front. We go 6x squared. Bring the 2 to the front. Minus 6x minus 12. And we're going to solve that equal to 0, aren't we? I'm going to divide by 6. I'm going to solve that equation. It's going to be x minus 2 and x plus 1, okay? You do that whichever way you can. Minus b formula, factorizing, doesn't matter. Okay, then what are my 2 answers? Okay, I'm going to pause there. I'm going to have to find the maximum and the minimum point now. I got the 2 x values, but I also need to get 2 y values. So the only equation that has y in it is this one here. So actually, you guys can save me a bit of time here. Okay, so here's what I'd like you to do. Half the class will use sub in 2. So this half the class subs in 2. And this half the class subs in 1. Then we can all save each other some time. What is it? And minus 1 for that side of the class, yeah. 2 times minus 1 cubed. You guys are doing the green one. They're doing the black one. So, what do we get? Any answers, lads? So 2 and minus 8. What did you get? Minus 15? And you guys did minus 1, and what did you get? Lads, there's got to be more than Ushin doing it over there. Who did minus 1? What you get? What you get? You got minus 112. Because you got the x side is minus 1 and the y value is 12. Is that all right? You good? Okay. Now, generally speaking, the one that has the higher y value has to be what? The one with the higher y value is always the max. Has to be. Because you're going up and you're coming down. However, that's not accepted in the leaving cert marking schemes. In the leaving cert marking schemes, we're going to have to differentiate a second time. So here we go. That's the first derivative, isn't it? Everybody see it? So what's the second derivative? Exactly. Second derivative is 12x minus 6. Okay? So d2y dx squared is 12x minus 6. Now, can anybody explain to me? Everybody agrees that the yellow one is the maximum? What are you expecting to happen when I replace minus 1 in there? What are you expecting to happen according to the notes? Has to be greater than 0, does it? Oh, sorry, it's the max. It's the max. So the max is, yeah. Is minus 18 less than 0? That indicates it's a max. And what happens when we sub in the second derivative for the minimum, which is the blue one? Yeah, we're going to get positive 18, aren't we? Which indicates that it's the min. Okay. Now, guys, we're going to see something called point of inflection. You ready for this? And I took the liberty of drawing the diagram earlier. Okay? So this is the diagram. If you were to put this into your table function, you'd end up drawing this diagram here. Okay, everybody cool with that? Now, I'll make it smaller, obviously. It's a bit on the whopper side at the moment. Okay. A smaller whopper burger. Now, everybody cool with that? Now, a point of inflection happens directly in between a maximum and a minimum. You got it? It's like the midpoint. So the point of inflection will actually be, see the way that's minus 2 and 0? The point of inflection will be located at minus 1. Now to accentuate what I'm talking about, right, it looks something like this. I'm just going to make it a bit more extreme looking, all right? So imagine that's your blue point and that's your red point. And imagine you're going skiing, all right? A point of inflection is, see the way it's sort of like the curve is bending outwards, yeah? And then at this point, it's bending inwards. The point of inflection is the point at which the curve changes from pointing outwards to pointing. If you were going skiing, you'll notice that this is the point where you're going fastest, just before you start to decelerate. Okay, so you've gone through the acceleration and now it's starting to bend the other way. That clear, you guys? It's obtained by getting, once again, not in your tables. You should probably take a note of this. Okay, and it's the second derivative equals 0. Now, all I'm going to do is differentiate twice. You got it? Differentiate once. We get 3x squared plus 6x. Differentiate a second time. We get 6x plus 6. Okay. I'm going to solve that equal to 0 now, haven't I? Because it's the second derivative equal to 0. We already knew that by the diagram, didn't we? We already knew it was going to be minus 1 by the diagram. It specifically says the point. So what does that mean? I need to go back and sub into the y value and I'm done. Is that all right? Okay. I'll put the homework on Google Classroom again. I need to find something that's appropriate, so it's going to be hard. the questions I have from this book are too difficult. The ones I've already recorded are just a little bit too difficult for tonight. So I'm going to have to find something else to do the trick. Is that right? So, and what do we get as the y value? 3. That's the point minus 1. 3, which is the value.